All right, given the position function of an object, so we have this position function, right, which we usually call s of t, determine whether the object is speeding up or slowing down at 7 pi over 2, right? So basically we want to find, when we think about speeding up or slowing down, we want to see speeding up means the signs are the same, right? And when I say signs are the same, we're talking about velocity and acceleration, right? So we want to figure out velocity and acceleration and figure out if the signs are the same or if the signs are different, right? That means slowing down, okay? And so really we want to find those values at 7 pi over 12, right? So we want to plug those in. So remember that, first of all, velocity is equal to the derivative of position, right? And then acceleration is the derivative of velocity, which is also the second derivative of position. Okay, so remember those relationships. And so so really this is what we want to find, right? We want to find acceleration and velocity, then we'll plug in 7 pi over 12. So let's go ahead and do that. So first, velocity is the derivative of position, right? So I want to find the derivative of this, and it's a trig function with a little bit of chain rule in there because we have an inner function here, right? So that 4 is it's just a constant multiple rule, so it's just gonna tag along. The derivative of cotangent is negative cosecant squared, right? I'm gonna keep the input function the same, and then I'm gonna multiply by the derivative of the input function. So the derivative of 3t is just 3, right? And so that's kind of what we have there. Constant multiple, that 4 just goes in front. Derivative of the outer function is negative cosecant, keep the inner function the same, and then multiply by the derivative of the inner function. All right, so now I'm going to simplify a little bit here. So I'm going to combine the 3 with the negative with the 4, and so I'm going to end up with negative 12 cosecant squared of 3t. Okay, and that's our v of t. All right, so now I want to find acceleration. So acceleration is the derivative of velocity, so the derivative of what we just found, which is also the second derivative of position, right? And so here we have a situation where we have a double chain rule, because now we have an outer function, right? And then we have a first level inner function, and then we have a next level inner function, right? And so I'm going to do the derivative of the outer function first. So I'm going to take that 2, I'm going to multiply it in the front and subtract 1. So it'll be negative 24 cosecant to the first, right? But I'm going to leave that 1 out because it can be invisible. Keep the inner function the same, right? So notice how I kept the cosecant the same and I kept the 3t the same, because remember, all those are inside. That's all inside of that exponent, okay? All right, and then now I'm going to multiply by the derivative of the next level inner function, which is the cosecant of 3t. So derivative of cosecant is negative cosecant cotangent, right? So I'm going to cosecant cotangent, and then I'm going to put that 3t inside there, right? So I have that 3t, that's the inner function, okay? And then finally, now I'm going to multiply by the derivative of the inner function. So the derivative of 3t is just 3. Okay, so that was a lot there because we had a really three-layer chain rule, right? We had a function within a function within a function. All right, so now I'm going to kind of clean this up a little bit. I'm going to multiply the coefficients together, 3, negative 1, and negative 24. And so that's going to end up being positive 72. Right, negative times negative is a positive. 3 times 24 is 72. Then I have a, let's see what color here. I have a cosecant 3t with another cosecant 3t, so that's going to be cosecant squared of 3t. Okay, and then finally multiplied by a cotangent, right? That's the only thing we have left. So cotangent of 3t. All right, so that's our A of t. All right, so now what we want to do is we want to find those values at 7 pi over 2. Okay, so I want to find v of 7 pi over 12, excuse me. I said 2 a minute ago. So what I'm going to do is I'm going to put in 7 pi over 12 there for v. So it's going to be negative 12 cosecant squared of 3 times 7 pi over 12, right? And 7 pi over 12 is 3 over 1. So this reduces to 7 pi over 4, right? So it's really negative 12 cosecant squared of 7 pi over 4. Okay, so then what I'm going to need is my my trig chart. So let me grab that. All right, so I have my trig exact values table here, and I want to find cosecant at 7 pi over 4, right? So I'm going to line up cosecant with 7 pi over 4, and that gives us negative, sorry, I couldn't see it for a second, negative root 2, excuse me. All right, so I'm going to put negative root 2 in here, and I'm going to square it, right? Because this square applies to that whole value. Okay, so cosecant of 7 pi over 4 is negative root 2. Then we square it because we have that there. So then we'll have negative 12 times all that squared. And remember that we don't really need to know the answer to this or the exact value. We just need to know if it's positive or negative, right? And so if we square a negative, we get a positive. And then if we multiply that by negative 12, we get a negative, right? Negative times a positive is negative. So we know this doesn't come out negative. It happens to come out to negative 24 because this squared is just positive 2. So 2 times negative 12. But anyway, that's so really what we want to know is that this is negative, right? That velocity is less than 0. So now let's do the same thing with the acceleration. So now for the acceleration function, I'm going to plug in 7 pi over 12. Okay, the acceleration function is 72 cosecant squared of 3, and then I'm going to put in 7 pi over 12 there. Okay, times cotangent of 3 times 7 pi over 12. Okay, so we know that just like this, both these are going to come out to 7 pi over 4. So it's going to be 72, or let me actually write it below here. So it'll be 72 cosecant squared of 7 pi over 4, cotangent of 7 pi over 4. Okay, so we know just like before, we already found this, right? This was negative root 2, the cosecant of 7 pi over 4, and then we're going to square it, right? 72 is still there. So now we just need to find cotangent of 7 pi over 4. And so cotangent is right here, and 7 pi over 4 is right here. So that's going to be negative 1, right? So I'm going to plug in negative 1 for that. This time we're not squaring it because there's no exponent here. And so, so we just have negative 1 times that. So now when we multiply these together, we get a positive. This will turn positive times a negative, right? And so, so we see our answer is going to be negative. All right, and that's all we really need to know, that it's going to be negative. It turns out that it's going to be negative 144, because this will be 2, positive 2, and that times 72 is 144 times negative 1 is negative, right? All right, so now that we know that the signs are the same, that means this object is speeding up, right? So we can say, you can just say speeding up, or you can say the object is speeding up. Okay, so that's our final answer, and that's because we just verified that velocity and acceleration have the same signs at that particular point. All right, so that's how you do number 8.